Welcome back. Today we will talking about Google Spreadsheets, especially forecast, regression, data fitting, interpolation and extrapolation, about charts and forecasts, and also a few words about Pearson correlation coefficient and coefficient of determination. What is that value is squared value from Pearson correlation coefficient and represents accuracy of data fitting. And we'll also try to make forecast using real COVID-19 data and a little bit more. So let's start. First of all, we can download COVID data with actual records. Follow this link and try to download this. We can download this. I have already downloaded to my working folder. First of all, we need to preprocess our data because there are many variables present, many columns, and much more rows present. We have actual data about different regions, for example Asia and so on, and a different country, Gabon and so on, Kuwait, many country and regions. We need to preprocess this data, for example using OpenOffice or something else, any spreadsheet editor you have, because if you try to upload this file to the Google Drive and try to open this using Google Spreadsheets, you will get error. If you try to open this from your Google Drive, open with Google Sheets, you will get error, sadly, but limitation present. So we can delete unnecessary records. For example, Ctrl F, search for Ukraine. For example, this. Wait a little bit. And we can see first record related to Ukraine highlighted. We can start from previous one and delete everything up to the second row. Don't delete headers and remove rows, delete rows. We can find down last record related to Ukraine. That's one. Highlight next one, scroll down and delete all other rows. Just records for Ukraine we can left. Even more, we can left just necessary content. We can delete these columns. As you know, by default Excel recognized each variable as separated rows. We can delete that variables, delete columns, just left location, date stamp, total cases, that's all. We can delete all unnecessary variables. We have many records, like total cases, deaths per day and so on. and some calculated records like median value and so on. We can delete all of them. We can highlight all that's columns, options, delete. I'm using OpenOffice to edit this content. Okay, we have just location, date and total cases. We can save this and upload to the Google Drive. Next move. As usual, we need to log in into our Google account, gmail.com. After that, we can navigate to the Google Apps menu and Google Drive. And Google Drive. After that, we can navigate to the My Drive and create new folder. New folder. Make a title. I have this already. I have a folder, My Drive, YouTube, Forecast, Google Spreadsheets. And in addition, I have 3 files present here. It's links, Ukrainian data, COVID data just related for Ukraine, and ready to use file. As a result, we will have something like this. It's just for reference. Okay. We can start new file, new Google spreadsheet. If you shared it previously, you can confirm shareable permissions. Okay, we can wait until all compilation will be processed, and we can open our Ukrainian COVID data also. Open this file. Wait until processed. So just 3 variables left. We can highlight these variables, entire columns content, copy and paste. Okay, we can close this COVID database file. So first of all, we can modify this plain text into the data format. We can recognize this by alignment. If this data alignment left, it means just plain text present here. If content aligned right, it means system recognized it as numerical data or data timestamps respectively. So we need to modify this. Let's scroll down and explore how many records we have. Last column is 773. 773. We can keep it in mind. Okay, we can highlight all this manually or using this option. Name box. B2 colon B773. Okay, it's highlighted. Format, number, but not a number. date, it's recognized correctly. We can see, for example, 15 of January, of June, 15 of June 2020. Okay, it's recognized correctly, but in addition we can change representation. Format number, but not a number. Custom date and type. And select predefined mask or create custom mask. Like this. For example, let's select this one. Let's select this one and click apply. Okay, everything recognized correctly and aligned right. Okay, it's correct. We can jump to the B773 and check this. Okay, recognized correctly. Very nice. Pretty cool. Okay, you can collapse this menu or unroll. You can collapse this menu or unroll it back. And you can rename this file. For example, temporary demo. All changes will be saved automatically. We can check this file. This file should be present here in this folder. Yes, that's it. We have this file present here. Okay, next move. We need to add another variable helper. It's a record counter. Insert column left. Let's make it header counter. Okay, we can attach just plain numbers for these records 1, 2, 3, 4, 5 and so on. We can use built-in formula row without input arguments. This formula return current row -1. Enter to apply, and we can see suggested autofill. We can confirm, and it's propagated down automatically. Let's navigate and check. 773. Navigate to the last one. Okay, everything correct. Nice. But it doesn't matter. We can delete some content and propagate it down. It's processed correctly. To propagate it down, we can snap bottom right corner, drag and drop. Right. Okay, next move. We can navigate to the last record, 773, and make forecasts. For example, 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. That will be our forecasts. We can make a sub header. We can merge cells first, and make some header forecast, and center this format alignment center, format alignment middle. Change text rotation. We can do this. Rotation, rotate up, and fill something, for example, gray. Okay. Well, that's our forecasts. Other forecasts. We can append known records by horizontal line like this, border, upper border like this. Okay, next move, we can use built-in function to make this forecast. In general, there are two ways. First one, we can use built-in function, and second one, we can tweak charts and use that option, forecast series in a chart. Okay, let's use forecast function first. Forecast function Excel. Let's refresh this. We can see syntax like this, forecast and so on. Let's try to apply this. 773. Okay, we can try to make first prediction. Okay, equal sign to start typing a formula. Right now we can use round to make standard rules of algebraic rounding, and insert this formula, forecast. Okay, what we should attach? X. It's a current X variable. We can pick up current X variable. It's our counter. Known Y's. We can tweak this. Highlight few records from total cases and change range D2 till D773, and we can switch this part, its relative part, relative range. Press F4 to make it fixed. The same for known axis. From C2 to C773. Apply. Nice, it's calculated and rounded. We can drag this and propagate it down. Okay, that's our forecasts. Using a built-in linear technique. Discard borders, no borders. Clear this. Okay, but in addition, we can make interpolation, not just extrapolation. It's our extrapolation, and we also can make interpolation. Just copy a formula. Copy, highlight range, and special paste special, formula only. Something wrong. Okay, let's try again. Jump to the last. And oh, that is as mentioned previously. It should be fixed like this. And we can highlight entire propaganda. It's down first. Clear borders. Copy this formula. Copy this content. Highlight entire range. Highlight entire range. Right click. Paste special formula on. Okay, it works. It's not realistic, of course, but as is, it's just a built-in formula using linear technique. It's just estimation of linear trend. Okay, let's make a header formula. Okay, as mentioned previously, there are at least two ways how we can make forecasts, interpolation and extrapolation. We can use built-in formula, but in addition we can use charts, such feature like Trendline. Okay, we can highlight X and Y's, navigate to the insert chart. We can switch chart type and use scatter. Verify x-axis, its variable counter. Okay, it's correct. Next move, we can customize series and use this trend line, the same as built-in formula. In addition, we can switch on r squared value. It's our coefficient of determination. That coefficient represents an accuracy of data fitting. That is, and can vary from 0 to 1. Why? Because it's calculated from Pearson's correlation coefficient. Using this formula. As you know, Pearson correlation coefficient represent an similarity degree between two vectors, two data sets, and can be varied from -1 to +1. If we have +1, it means similar data, maximal similarity. If we have -1, it's anti-similarity. Our data flipped vertically. If we have zeros, it could be, for example, two white noises. There are no similarity between data sets. That is, it's Pearson's correlation coefficient. This dashed value means centered, sample mean, and we can use this explanation kindly provided by this source. Its coefficient of determination, and it could be calculated from coefficient of correlation, Pearson's correlation coefficient. It's just squared value of Pearson's correlation coefficient. And we can download this template to calculate coefficient of determination. As you know, we can see this calculation. X, it's data points for the X data set, for the first data set, Y for the second data set, M, median of this data set, respectively. We can download template kindly provided by this resource. Okay. We can use custom label, but not. We can use equation instead of custom label. We can use this to calculate it manually. Let's imagine a situation. We have many records, and we have to know values for each appropriate value. It's not good practice to fetch data from graphical series, but instead we can calculate it manually using this built-in feature. We can copy this equation. Trendline. Okay, back in to the customize series and trendline. We can see few trendline techniques present here: linear, exponential, polynomial, logarithmic, and power series, and moving average also. We don't touch this today. Okay, 1, 2, 3, 4, 5. In addition to the formula, we have 5 techniques. First one is linear. Okay. In addition, we can provide R² value for each appropriate data fitting techniques. Okay. Double click to edit text. Left Alt Enter to insert a few lines of text in a single cell. R² value equals 0 point. So at this point I can copy this content like this, highlight, copy, and paste this 5 times. 1, 2, 3, 4, 5. Like this. Nice. In addition, I can make a choice about colors of each appropriate curve. So let's consider this will be filled by black. It will be black curve, default one. Formula. Okay, we can highlight all this. Alignment center. Format alignment middle. Border. Insert some borders. Okay. Formula. It should be gray. Linear. For example, it could be red. Next one, it could be yellow. Next one, it could be green. Next one, it could be but another. Let's, for example, it could be orange, it could be yellow, it could be blue, cyan, light blue, cyan. Let's could be cyan and blue. Okay. Let's consider it will be our colors of our cars. Okay, linear. We can copy this equation. And calculate these values manually. Okay, we need to replace x variable and pick up current counter value, current position in the flow. Okay, we can apply suggested autofilling and let's check. Last record 773. Okay, nice. It's autofilled. Not just interpolation, but extrapolation range also. And forecasts will be calculated. But in addition, we can insert this function round and copy this and highlight entire range. Seven, 8, 3. Special paste, formula only. Okay. As mentioned previously, Z values are the same. That means we have linear technique built in this formula. Nice. Next one. We can edit it. Customize series Trendline. Use another approach. Next one. Exponential. But linear first and provide this R squared value. .94. Customize series trend line. Use another approach. Exponential. We can copy this equation. copy this equation and provide this exponential 954. Okay, and insert formula equal sign, round, and paste this. We need to replace exponenta multiply by exponenta. We can use built-in function exp like this, and replace this content of degree multiply by current position. Nice. Enter and autofill. Next one. Customize. Series. Trendline. Polynomial. As you can see, we have polynomial degree 2. We can select an order of polynomial. As you can see, we have second order x squared. We can select third order. We can see x in the degree of 3. Okay, let's be solve polynomial. We can copy this equation, make a header polynomial, and provide a squared value 981. Okay, and calculate its manually. Equal sign, round, insert this. Next move, we need to replace x variables by current position. Multiply by pick up current position. Even more, we can copy this portion of code and replace it by this code. We can insert brackets if we need to make this equation inline. Okay, enter to apply and autofill. Next one. Customize series. Trendline. Logarithmic. Maybe it's worst because these shapes inverted. We can see something like exponenta and this antipode logarithm. But let's try logarithm. We can copy equation, make a header logarithm and r squared value, and insert a formula equal sign, round, and replace. make this inline, make this inline, multiply by logarithm x, log x, but replace by current position and autofill. And next one, customize series trendline power. It's a power technique. Okay, we can copy this equation. We can copy this equation, make a header, power, r squared value, and insert formula equal sign, round, and replace this content, multiply by current position. Okay, autofill. Nice. Let's check it again. Let's check this again. Let's jump to the last one. 783. Okay. We can restore this horizontal line, border, top border. Okay, that was values for known data. That's values for the forecast. That's all. That's completed. In addition, we can play a little bit. We can rename this current worksheet also. Okay. In addition, let's combine few graphs in a single chart. For this, we can delete current chart, insert new one. First of all, we have to highlight all variables of interest. It's recommended our OX variable, OX data, OX values should be left-sided. Insert chart, change it type scatter. Let's prettify it a little bit. Customize. Chart style should be modified. Chart title, for example. Like this. COVID-19 Ukraine. We can customize legend, position, top, for example. And And it's most important, we can customize this series representation. We can apply settings for all series at once. For example, 2 pixels, or one by one, total cases. It could be total cases. It could be black. Let's make it black. Opacity 100. Okay, and let's attach appropriate colors for each variable. Formula gray, opacity 50%, linear red, opacity 50%, exponential orange 50%, polynomial yellow 50%, logarithmic cyan 50%, and power blue 50%. Okay, it's completely everything completed. But in addition, let's calculate R-squared value coefficient of determination manually. As we can see, the best accuracy we have by applying polynomial regression. The worst is logarithmic. Okay, let's calculate it manually. For example, accuracy for total cases and poly. Let's do it. For example, Pearson's correlation coefficient. Pearson's correlation coefficient. Pearson's correlation like this, PCC. We can use built-in formula, Corel. Pearson's product moment correlation coefficient. Two values. First one, total cases. From D2 to 773, possibly, maybe, or 783. And we can round and left just 3 quantitative just 2 digits or 3 digits after comma, 3 for example. We should provide another argument, polynomial h773, maybe 783. We will check this a little bit later. Maybe. Okay. Maybe 783. Okay, very close. 773 and 773. It's our range for interpolation. It's coefficient of Pearson's correlation. Let's calculate this one, coefficient of determination. Code coefficient of determination. It's just a square value, equal sign, pick up Pearson's correlation coefficient and in the degree of 2. Okay, perfectly. Maybe really try this. 783 and 783. Okay, doesn't matter. Very close. Very close. Okay, let's calculate it. Let's verify our results. Okay. We can use Python to calculate these values. And this code. We can just replace that values by values of our own. Okay, let's copy total cases. From D2 till D773. Ctrl C. Let's insert another worksheet, or just use any editor. Replace this, Ctrl H, replace this by commas, comma space, replace all. Nice. Insert and delete this. The same for polynomial. We can try maybe such options as present in Excel application, also present here. Remove. Let's try. Seven, 7, 3. Copy. Special paste. Yes, it's present. Transposed. Oh, but not so easy. But not so easy. Control C. Special paste. Values only. Control X. Special paste. Transposed. Okay. Right click, special space, transposed. And we can delete entire okay, we need to wait a little bit until processed. And delete entire column. Copy all this and paste. The same. We can replace this in text editor or transposed in Google Spreadsheet. Okay, we can run this and take result. Oh, we need to insert commas between that values. Highlight, replace, comma, space, replace all. Nice. Highlight all, Ctrl A, Ctrl C to copy, and oh, mistake, Ctrl X. Ctrl X. Ctrl C again, Ctrl A, Ctrl V, highlight, Ctrl H, replace all. Ctrl A, Ctrl C, Ctrl V. Okay, let's run again. Okay, we have Pearson's correlation coefficient like this. Something strange, but let's be so. Okay, let's calculate it manually by different way. maybe something wrong. Let's copy again and replace. Okay, let's be so. Let's try to calculate it manually, like this. I have already predefined formulas. Kindly provided by these resources for all users. You can just register and download their files. Sorry, Z files. Z files. You can just register and download their files. This one. I just use this file as a template to make calculations. We can copy a portion of code from this to my file. Pearson correlation coefficient and coefficient of determination. We can delete all this content and paste. Okay, polynomial in our case, polynomial regression. Okay, let's copy values. Total cases. 773. Copy and paste. The same for polynomial. Colon H773. Copy. Special paste values only. Okay. Next move. We need to calculate difference between each x. X is our first variable. Y is our second variable. We need to calculate difference between current value of the first variable and middle average value from entire variable. Copy like this. 773. And we can propagate it down. Ctrl C. Special paste, formula only. Let's check. Okay, it works. It works. The same for another variable, poly. Current value of the variable and minus average value from entire variable. Copy, highlight entire range, special paste, formula only. Okay, this one. It's a square from each previous value. Okay, just a square. Just a square from this value. Okay, it works. Ctrl C, highlight entire range, special paste, formula only. The same for the second variable, poly. Okay, and almost last one, this. It's multiplication between those two differences. This one and this one. Okay, in addition we can calculate these parameters. Okay, it's a sum of all calculated iterations, sum for this squared value and sum for that squared value, and it's just squared value rounded for the 3 digits after comma. Okay, it's pretty close to the automatically calculated. This one don't calculate it properly, I don't know why, but maybe something missed. Okay, it works. Okay, thank you for your attention, but in addition I can try to calculate z coefficients between few variables. But next time. Thank you for your attention.